Alright, so welcome to day 13 of Advent of Code, and today I'm going to use C++. No particular reason, I just thought it's gonna be fun to just use it and get it out of the way, and then maybe we'll see more interesting languages after. So let's see what the problem is about today. So we get into the lobby of a resort. This is another Advent of Code day, interesting. And some hexagonal floor, and then we find an arcade, and there are some claw machines. I think it's like a Wikipedia thing. Okay, so it's those crane stuff that gets a prize, and you have buttons to move them. Okay, so it says here that it only has two buttons labeled A and B, and worse, you can just put a token and play. It costs 3 tokens to push button A and 1 token to push button B. So we can see that it's this kind of difference. I mean, just push button B because it's cheaper. With a little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis and a specific amount forward along the y-axis. Makes sense. Like judging by what I see here, it makes sense. So each machine contains one prize, and the claw obviously must be positioned above X and Y. So here we have the way button A moves the claw, we have the way the button B moves the claw, and I am assuming we start at 0, 0, and we need to get to these coordinates. If possible, maybe it's not possible to get to them. So we wonder what's the smallest amount of coins or tokens, I guess, that we have to spend to win as many prizes as possible. So I guess the prize doesn't really have a value. It's more like you won or you didn't. So what we're gonna do is maybe just try to find the minimum number of coins. Okay, interesting. So somehow this makes me think that this looks like a formula, right? So let's see what it's about. So this describes the button configuration. Probably is like the puzzle input. Let's see what the puzzle input is. It's kind of big, but I imagine someone could do it by hand. So here, for instance, if we push the machine's button A, we get into 94 and 34 position. And if we push button B, it moves only 22 and 67. And the price is here. Okay, so how much do we move? Okay, so this is the coordinates, and the cheapest way to win the prize is by pushing the A button 80 times and the B button 40 times. So I can see that it says 80 times 94 plus 40 times 22 is equal to this number. So this already looks like the formula, right? So it's like this is how many we press A multiplied with the X number plus B multiplied with the BX number, and then we have A again multiplied with the Y number for A and B multiplied. I guess we can try to write out this formula and see if it's actually gonna work to use it to solve the problem somehow. And if we do this, we have a cost of 80 times 3 tokens for the A presses and 40 times 1 for the B presses. Now what's an interesting problem is that, okay, we can try to use a formula, but is it gonna give us the smallest number of coins? Because I also had another idea, but maybe that's a bit more complicated, to try and use a hash map for the, so the key in that hash map would be the current position, and the value would be how many coins it costs to get into that position. So it's like a DP problem, but we'll see if the first one works, because the first one seems much easier. It looks like it's just a formula, right? So it's a times x plus b times y, or I guess still x, but for the third claw machine, or I guess second one, there is no winning. The third one is 200 tokens, so it costs 480 tokens, something like that. And we estimate that each button would need to be pressed no more than 100 times to win the prize. How else would someone be expected to play? Okay, so maybe that's a constraint we can add to our formula to get the minimum, or something like that. Or I guess, oh, you know what? This is to figure out if it's doable or not, because if you go above 100, then if you multiply this number with 100 and this number and you add them together and it's still too small, then you cannot win or something. Okay, so yeah, that's I think the other constraint. So we have to figure out the fewest tokens we have to spend to win all the possible prizes. So yeah, let's try to draw the formula and see if it's possible to do it like that. And if not, I mean, we can always use a hash map. But yeah, let's see. So GIMP already open because I just knew it's gonna be needed. So let's do the first one, right? So from what I can see, the formula is gonna be something like, okay, so let's try to use actually Python. So we have 94 times 67 minus 34 times 22. This is gonna be the thing that's down here. So it's 46 1 0 1 over that, and then we have the following stuff. So it's this multiplied with this, so it's gonna be 94 times, wait, it was 8400 100 minus 22 times 5400, so that's gonna be, I don't know why I copied it, it's gonna be the first term, and then we have minus 34 times 8400, yeah, plus 60, so it's this multiplied with this, 67 times 5400, so this is the second one. So now to get the number of A pushes, we have to divide this by 4610, and see, it's too many though, it's 127. And for the second one, the second number of pushes, wait, what the fuck, it's only 16. Huh, so that sucks, I guess. But how can we avoid that? Right, how can we avoid getting too many button pushes? Let's think about it. So it's it could be, so really it's really gonna be like that, 127 times 84 plus 16 times 22. It's too much. I think I did a whoopsie doopsie in the, oh, it's 94, not 84. So when I did here the calculations, it was 94. So the first number is wrong then. Wait. here it should have been 94. But even then, oh, and the second one was 67. What the fuck am I doing? So it's 94 times 67 minus 34 times 22. So it's like this. And then the first number is 94 times this. So is still not good. What? Maybe I did an oopsie doopsie here, but they say AD minus BC. Yeah, I guess. So isn't this, I mean, I think this looks good. So you multiply this one with this one, so you get the, it's like the formula itself. A times X is equal to B or whatever, and you get the, you get to multiply with 8 to the power of minus 1 on the left side. And 8 to the power of minus 1 is this trash. I mean, we could use the, so this matrix, we know what values it has. We can try to use the Wolfram thingy to get the inverse. So let's see, Wolfram. That was my go-to in math classes. So if we do inverse and we put here the matrix, so the matrix is 94, 34, or wait, it's XA, XB, so it's 94, 22, and 34, 67, 34, 67. What? I mean, it's using this kind of notation. I mean, whatever. So this is, I mean, we have this, right? 1 over 555. I mean, this is, no, it was 5550, and then 94 minus 22 minus 34, and oh, A and B are reversed, of course. So this is 67 and this is 94. Wait, I missed that. Okay, so this is actually YB and this is XA. My bad, I didn't read the formula correctly. So it's the other way around, right? So we get 67 times 8400 plus 94 times 5500, and that's gonna be first number. And if we divide it with 5550, it's even bigger. What the fuck? But how is it wait, how is it bigger though? Because before, oh, I don't know if I'm calculating. Okay, so here it was minus 22 times that. Okay, and if we divide this guy by 555, oh my god, we get 80. And that's the thing from, yeah. Okay, so that's close. And then we get the second line, which is minus 34 times 8400 plus 94 times 5400. And what is the negative? And if we divide this guy by 5550, we get, okay, my bad. So I did the formula wrong there. So it's YB, and here it's XA, right? So that's not following the instruction correctly, but it feels like it should work, right? So we did the hard part, we figured it out that it works with this formula. So the goal now is to just read the input and solve it. I mean, at this point we can just use any language, but I'm still gonna use C++ because why not? So yeah, let's see if we can actually solve it. Okay, so let me just create the shell and then we can go to Day13. So let's have main CPP. Okay, I wanted to use C++ because I already have, it's basically already installed. Wait. Cout. Hello. Like, because I installed this, I'm not sure how it's already installed though. Maybe it's because of. Right, because I have G++. That's weird. Okay, and it runs. Now it's interesting. CPP read entire input. Like this one should also have a function that's std get line. How to read until end of file. I guess with get line, right? So that's not really a good way of reading. We just have to do it like this. So while we can get a line from stdin, we can have a vector you know, like maybe what would help here is a structure for the claw machine. So let's try to use a struct, or even type def struct claw machine, and it's gonna have interesting. So I should follow the same naming convention I had here. So XA is gonna be so let's use long X A. This is the 94, for instance. Then we have long YA, long XB, long YB, and then we have X and Y. Long X, long Y. So we have all of these numbers. Perfect. How can we actually parse this entire thing? Can we maybe have an std string buffer, and we do something like buffer append we can append the line or something, and then we can print the buffer out. Okay, so what I'm gonna do is create this tmp file with this stuff. And let's see what happens if we run main and pass in tmp. Okay, so it doesn't also append. Can I like a chart? No. What? We can append the new line at the end. Okay, so that's how we read the entire buffer. Interesting. I guess I could have an std string read input is gonna basically be return buffer, and then we can have std vector claw machines, and we are going to do parse input. Yeah, I mean, I said that I'm going to do like a meme and program in C++ like in C, but I think, you know what, it's much. I guess we have ds.h in C, so we can try to do the same there, like the same kind of structures, but we'll see. So what I'm going to do here is std string input is equal to read input, and then wait, claw machine like machines is equal to parse input, and we pass in the input. Nice. So that's how we get the thingy. Okay, perfect. Oh, you know what, I didn't check if it actually worked, right? I didn't check that. Why does it abort? Ah, because this doesn't work, yeah, obviously. Curious. Okay, yeah, so it works. Perfect. So let's try to parse this thing. So buffer.split, we don't have split. CPP split string, that's using the limiter. So we can use substring and can do sfind. Can we find double new line? Alright, and fine, what does it return? It returns unsigned long. If found, it returns the, but what if we don't find? If not found, it returns npos. What the fuck is npos? Well, we'll find out what npos is. Maybe it's like the last number. So I might do something like for like, I saw it's an unsigned long index is equal to 0, or I guess is equal to this thing. No, I'd rather just do like unsigned long index is equal to 0, and then we can say while index is less than buffer.length. What I'm gonna do is index is equal to buffer find double new line, and we pass in the index as well into it. Okay, and I'm also gonna declare this vector std vector claw machines, and we return machines. So what I'm curious is, yeah, cout index, and then end line. All right, that was also a trick. Oh, end pause. So what's the buffer length? Is it ooh, I don't get it. What's end pause? It returns end pause. So end pause, is it the unsigned long new index? If index is equal to index, then we break. Huh. The fuck? Ah, no, I forgot to say index is equal to new index. Okay, okay, I get it. So new pose is the pose, but it's not even right, because it's 0.63. I mean, I should print new index regardless of that, but 63. So it finds it here, but then why doesn't it find it again? Ah, it's index +1. Maybe. What the fuck? Oh no. So it's like here it's a 63, here it's 130, here it's 195, and then is this end pause? What the fuck? CPP split end pause. What is end pause? Ah, it's a thing. It's -1. Oh. Okay, so it's index. So it's interesting. So if index is equal to end pause, oh, it's string end pause. I guess std string end pause. Then we break. Okay, makes sense. So we don't need a new index. Okay, and I think I'm gonna do index +1 because why not? So that's how we are gonna get the positions where we need to split. And this guy was saying what you have to do is use substring. And well, actually that's a good point. We might want to have a pause, let's say. So index is going to be the starting point. And pos is going to be where we stop. Token. Well, here's token. This is the machine basically. So here is the buffer. So we just print the machines. Oh shit. I forgot to say index is equal to pos at the end. Okay, we get something weird. Let me just put some, I don't know what, it's actually easier to figure out where you are if you use the weird, so I'm printing, I need to do a plus. Wait, but why does it print these two things here? The fuck? And then this one is 17 and also this one. Wait, that's weird. Because I'm also doing this print here at the end, so see how it, so here it prints from 0 to 63, then from 63 to 130, but I feel like it's too much. It should be only up until this point, and then 130 to 195, and then should also be this one. I guess substring doesn't break anything. Well, I mean, I could even say index plus 2 here just to be sure, but okay, what the fuck? Buffer find. Buffer find. This stops on the starting position, so it's fine. I guess I could also say plus 2 here just to skip the new lines, but why the fuck does it do that? Well, I will C++. Like the first one looks good, but then the second one is 2 lines. Huh. It's split by lines. Like, come on. I mean, that's literally what I did. You know what? Let's try to copy this function because I'm annoyed. So it's like returns a vec of strings. I want to, we have the vec of strings, we have the initial position, we have the previous position. Position is equals to string find delimiter and previous. That's what I did. While it's not equal to npos, strings pushback. Wait, substring doesn't work as I thought it does. It's oh, it's position and length. For fuck's sake. I mean, it's an oopsie doopsie. Okay, now I know. It's so we have std vector of std string. I guess we could just iterate. So split string, we give it buffer and double new line. Can we do like begin to do an iterator? For loop, I want a for loop to do it with for loop vector. Yeah, something like this. Oh, you can use auto. I forgot about that one. So I can say for auto iterator is equal to begin vector. But I still have to see. It's like items, or I use parts begin iterator is not equal to parts.end and plus plus iterator. So that's how we get the iterator, which is just a string, right? So if I do cout iterator end line, wait, I thought iterator is gonna be a string, right? Oh, you can even write it just like this. Huh, that's even better in my opinion. So parts, that's the Sigma way of doing it, I guess. Nice. So if I print something like exclamation point just to mean it, you see it's like first one, second one, third one. I have a inside of read input. Can we buffer.strip trim? Shit. String cpp remove last character. Can I remove the last character? Pop back. Yeah. Hopefully this removes it. Let's see. Nice. Because the last character is a new line, so we can just remove it. Okay, perfect. So now we have the first part, which is the splitting this by new lines. Damn. So the next step is to split it let's do something stupid, like let's split it by plus, and that's gonna give us this thing and then this thing. Then we split it by comma and we get the first one, and then split by plus again. So if I do split string parts plus, right, I'm gonna get this thing in the second element. So I mean, that's kind of lame, but I can even pop front. No. Can't I just take the... Wait, what? I want to split part. Yeah, I was like, what? So 94 and Y. Ah, wait, yeah, it's true. I have to do something else. I have to say auto lines is equal to split string part by new lines. So now we get all the lines. And now I have to do my thing with getting the x's. So I'm gonna do on the first line, let's split by plus, or I guess let's split by comma. It's easier. So I'm gonna do split string lines 0. We split by comma. So that way we get this thing and this thing. And now we split by plus and get the second items. I mean, imagine, yeah, that could also work to use just SN scan or scanf, but so auto tokens. But honestly, I would rather have std vector string lines and tokens, so I can just reuse them. All right. And now it's like xa is gonna be split string tokens 0 by plus, and we take the second one, and auto ya is gonna be just like this, but we take the other one. So if I say xa ya, I should see the numbers. Oh, it was so slow, you saw that? The fuck? Okay, so it splits the strings. Perfect, so I can do the same thing for xbyb. Oops. and we get that. Nice. And the last thing is to do almost the same thing for x and y, but instead we split on equals. Was that right? I think it is, yeah. Oh shit. Lines 2. Right, so we get the things. So we can just build a claw machine. Nice. So I would say, let's say claw machine is equal to, and then x. I mean, I called it xa. Ya is ya, xb is equal to xb, and yb is equal to yb. Oh yeah, the only thing we have to do is to call atoy on this stuff. Wait, isn't that a function? It's const char. cp string to int. Stoy. Yep. std stoy, that's a good one. It's like string to int, right? It's but that should, I mean, obviously we could have done nicer parsing, but you know, as long as it works, it works. Oh. Yeah, I mean, obviously you have to put them in order. Okay, and at the end we do machines push back machine. Nice. Oof, so we were able to parse the machines. That was the hardest part, right? Parsing the thing. Now if we remember how I did the formula, we can just implement the formula, right? So formula is gonna be something like we can say it's gonna return a long, and it's actually solve machine, and it's gonna be either 0 or the number. So it's gonna take in a machine or a claw machine, and we have to compute all of these things. So first, let's say long denominator, it's the like this term right here. So it's xa yb, xa times machine dot yb plus machine dot ya times machine dot xb. So that's the denominator. Then we have the multiplications. So multiplications are gonna be this multiplied with this. So it's yb times x. So let's say long a is gonna be yb times x. So machine dot yb times machine dot x. that and that, so then it's minus xb, so machine.xb multiplied with machine.y. So there's the first part, and then b is gonna be machine dot, it's a negative ya multiplied with machine.x plus machine xa multiplied with machine.y. So that's a and b, right? The first item, then the second one. So after we have those two items, we have to divide them with the denominator. So it's gonna be long a presses is a divided by then, b presses is gonna be b divided by then. So let's return 0 and let's see what these values are. So std out a presses, let's put a comma, b presses, end line. So if we do for auto machines, I'm gonna do solve machine. Right, so we can get negative numbers, which means like you press the button negative, that's oh shit, doesn't look right though. 63 and 31. Oh no. Oh no. Okay, let's see if the denominator is fine. Oh no. 7,000. No, but it was something else. XAYB. Oh, minus, yeah, sure, minus. Yeah, now it looks good. Okay, perfect. So if, I guess if then somehow is equal to 0, then it's over. And then I'm curious how it's gonna look like on our input. So let me just nix develop, nix run AoC get. Let's get the input for Day13, and let me just try to run it on the input, Day13 input. So some of them are gonna be negative, some of them are way too big. So should I ignore the ones that are too big? That's the real question. Wait. Wait, what? Why are there so many? Whoopsie doopsie, what the fuck? Okay. Something's weird because these numbers were negative. It's because I'm using, yeah, no, it's fine, I'm using long. But they were negative a second ago. Were they negative because I was doing plus? Oh, I think so. Hmm. 38 and 86. Well, the problem is that these numbers are, like, it looks like they can be solved, right? So if I do something like 141 and 1, so we have what? It's like 17 times 141. That's the x, and then it's 84 times 135. Yeah, that's way too big. Wait, how does it work then, though? Like with this formula? I'm curious to see like the entire thing. So denominator, let's do a comma, let's say A, let's do a comma, let's do B, A presses and B presses. I don't know why it auto-completes it like that, it's strange. Okay, so now we should see all the numbers. So if the denominator is negative, okay. But then look at the last one. The last one is not with negative numbers. For the third claw machine, I guess the last one is too many presses or something, right? So that's what happens with the last one. So it's 244 times a 69 and 65 times 27, and that, but that's not right. I guess the other thing we have to do is make sure that the solution works. So like we get some numbers, but maybe it's that they need to be floats actually. So if I convert them to float, right, so it's yes, it's like floating numbers. Okay, so that's why they don't work. So what I'm actually gonna do then is check if the presses actually solve the problem. So long x is a presses times machine dot xa plus b presses times machine dot xb, and we do the same thing, but here we just replace x with y, and then if x is equal to machine dot x and y is equal to machine dot y, then we return a presses times 3 plus b presses. Otherwise we say 0. Okay, so long total total plus equals, so then we can say C out part 1 total end line. So that should be 480, and then what if we do our input? It's another number. So yeah, that actually works. It's tricky, but yeah. So let's see what oh shit, let's see what the second part does. So as you win the first prize, you discover that the claw is nowhere near where you expected it to be. Due to a unit conversion error in your measurements, the position of every puzzle is actually this much higher on both X and Y. Glad we didn't do brute force. I mean, add this much at every X and Y. Okay. It will take many more than 100 presses. What is the fewest tokens? Okay, nice, interesting. So what I'm actually gonna do is solve machine is gonna take in a long offset, right? And for the first part, the offset is gonna be 0. So should I just say machine dot x plus equals offset? All right, so for the first part, it's 0. And for the second part, it's that number. I don't know. Does it look like the right answer? I mean, it's 2 digits greater than that one, so maybe it is. And it actually was. I mean, yeah, it actually was the right answer. Nice. Okay, yeah, I mean, for the second part, it was pretty easy since we did it the right way from the beginning. We just added this offset argument and just moved the X and Y positions. Hey, I guess it was an interesting day because of this formula. Yeah, glad we tried this one first, even though we had that start. I mean, yeah, hopefully, you know, it's this side. If you're still like doing math, it's really good for doing stuff like this, solving equations and stuff. The Wolfram one, pretty good. Yeah, I mean, you know, like C++, it's pretty easy to work with it. I did a lot of it in like solving problems like these ones. So, but you know, it's like never really used data structures like strings or vectors. We weren't really, not really like allowed to use them, but you know, like we had to use char pointers and stuff like that because that's yeah, it is what it is. It's but being able to just use other people's implementation, pretty cool. Like this function, we just stole it from Stack Overflow. Yeah, but I mean, it's like mainly because I didn't realize that substring takes length, which is pretty weird. But yeah, I mean, the solution, it's quite straightforward. It's just this formula, right? We computed the denominator and then just multiplied the numbers together to solve the equations. And then if the machine was solvable, we just computed the cost, and judging by the result, our guy is either very rich or it like it's the average gambler. Yeah, Jesus, 85 trillion. But yeah, I mean, I guess that's it for today. Maybe the last thing we have to do is the makefile. So obviously, let's do the makefile. So I'm gonna put here G++. I'm not even using the CC, but main.cpp minus L main, and it's Day13. Nice. So that's basically the makefile, and then I can go right into the flake and we can just copy paste one of these. I'm not sure, no, not the PyGet one, Jesus. Let's take the first one, which is also like compiled language, so it's fine. I think it's GCC, right, that gives you the C++ compiler. I'm not sure. We'll check. So Day13, we have the prefix, so then we just need packages.gcc, I think. So if I run nix run, so I have to also add all the files. I always forget about that. Git ignore, let's put the name as git ignore. So if I go back, let's try. Yeah, looks like GCC is actually what gives you the C compiler. It's interesting. So yeah, the last thing is to just add it in the list, and now we can just have also the Day13 solution, and then we'll put like C++. What should we call this one? Like professional, wait, no, it's the entire thing. It's like what professional competitive programming. Yeah, I don't know, like just a joke, because C++ is usually used by like competitive programming guys or girls, I guess. Like C++ and Java, they are the most used ones, even though Python is, I'd say, much easier to use in those kinds of scenarios. But honestly, by like comparing the experience with PyGet and C++, I'm gonna say that C++ was much easier than PyGet, which is Python. But it was also, I would say, yesterday was a harder problem than this one. Yeah, I mean, the only problem that I have with C++ is parsing. It's the C way of parsing things kind of sucks. Probably there is another way, but I'm just I never bothered to learn another way, so just doing splits. Because I only know how to parse differently in like something like Haskell, but yeah. Well, that's kind of it. So yeah, we got all the days so far running, all the outputs, nice. I guess the slowest one obviously still is prologue. I'm waiting for another one to take its place, but that's gonna remain the slowest one. Yeah, so that's all for today. C++, decent approach. Like parsing looks like trash, but the solution is pretty nice. So yeah, let's see tomorrow and see what the Day14 is gonna be like. Probably it's gonna be a harder one. Hopefully no graphs yet, because I don't like graphs, but who knows, we'll see. So let's see tomorrow.